In this calculator tips and tricks, we're going to learn how to use the financial functions in our financial calculator. So we have a problem, and I've already drawn out the timelines and the function for you. We have a lump sum, 24,000, and then we have this unknown annuity, and we'd like to figure out what those annuity payments are. So we have this is a PVA problem, present value of annuity. Now, in our calculator functions, we have N, since it's an annuity, is the number of cash flows. So we have 120 cash flows in the annuity. So we're going to take in our calculator and go 120, and then the N key. Okay, and then our interest rate is 4.6% APR compounded monthly. So we're going to take 4.6, and we have to turn it into monthly, so divide it by 12 equals this amount, and then we're going to put that in the I over Y key. We have the present value of these cash flows we know is 24,000. So I'm going to take 24,000 and put that in for present value. Payment is what we're looking for, so we don't have to put anything in there yet. And then the future value, we don't have any lump sums out here. This cash flow consists only of an annuity. So we're going to put 0 in for future value. Okay, so we want to solve for, and that's what I use over here as compute, is the payment. So we're going to go compute payment, and we see that the payments would be $249.89. Okay, now the reason in your calculator this comes out negative is because it's assuming that you got this $24,000. Okay, so that's an input into your checking account. You can think of it that way. And then these are cash flows coming out of your checking account. So that's why we have the negative here. Okay, let's do another one. Again, don't worry about the problem here. You can read it, but these are the cash flows. And we're looking for the present value. Okay, so again, we have 120 cash flows. So that N, when we have an annuity, is the number of cash flows in the annuity. We have our interest rate is 4% APR compounded monthly, so we have 4 divided by 12. And then we have our future value. Again, there's no lump sum over here, so that's going to be 0. And then we want to know what the present value is. Okay, so I'm sorry, I don't know if we do it 100 for our payment. And then compute present value, and we get $9,877. All right, one more to show you. We can do this. Sometimes we have to do more than one calculation. Here we have a delayed level annuity. So remember from that, we have to first convert the annuity into a lump sum, and it converts, that PVA converts the annuity into a lump sum just prior to when the annuity starts. So the annuity starts in period 60, so that lump sum equivalent is going to be in month 59. So first thing I do is I'm going to take, there are 300 payments in my annuity. The interest rate is 6% APR, but it's monthly, so I divide it by 12. There are $4,000 is each payment, and there's no lump sum, so the future value is 0. And I compute PV. So these 300 cash flows have a single lump sum dollar value of $620,827 as of period 59. But I want to know how much I have to deposit today, so I need to have a present value. So for simplicity, I'm going to clear this out, and now we're bringing this back 59 periods. So that's our N, because the N when we have a present value is the number of discounting periods. We have our interest rate is still 6 divided by 12. Our present value is what we're looking for. Payment is 0 because we've already converted the payments into a lump sum. And our lump sum is $620,827 in future value. And so we compute the present value, we get $462,566. And that's how much you would have to deposit today to fund these cash flows.